Another important characteristic of organic compounds is that they have low melting and boiling point, and because of low melting and boiling points, they are volatile in nature. For example, in all the organic compounds, the intermolecular attractive forces are weak. Now, with the slight increase in temperature, these intermolecular forces breaks, and when these intermolecular attractive forces break, the substance change from the liquid phase to the gaseous state. And we know that in the gaseous state, there is the greater distance between the molecules, and the force of attraction between the molecules, that is intermolecular force of attraction, is also weaker. Because of their capacity to get changed into the gaseous phase is more, therefore they are generally volatile in nature. This means that the intermolecular attractive forces between the organic compound is also weaker. So all the organic compounds therefore have low melting and the boiling points. Another important characteristic of organic compound is about their solubility. All the organic compounds that are non-polar in nature are soluble in ether, benzene, and carbon disulfide. These three compounds are generally the solvents. They are the non-polar solvents. For a solubility, we have a rule that like dissolves like. So this means that if an organic compound is non-polar, then it will be soluble in the non-polar solvent. If an organic compound is polar, then this means that that organic compound will be soluble in polar solvents. Now, all the organic compounds that are non-polar will be soluble in non-polar solvents, and the example of non-polar solvent are ether, benzene, and the carbon disulfide. Now, for example, we have a case like this. This is an alkane. Now, in this compound, we have a bond that is carbon-carbon and carbon-hydrogen. Now, since the electronegativity difference between these bonds is very small, so this means that there is no generation of any partial positive or partial negative charge in these cases. So therefore, we can consider these two bonds as non-polar. Since there is no generation of partial positive or partial negative charge because of lesser electronegativity difference, therefore these compounds will be considered as non-polar, and this compound being non-polar will be soluble in these three solvents. However, if an organic compound is polar, then it will be soluble in polar solvents like methyl alcohol and ethyl alcohol. For example, we have a case like this. Now, you may see here that we have two kinds of bonds that we will be discussing in a greater extent, C double bond O and OH. Now, these two bonds have considerable electronegativity difference, and because of the electronegativity difference, there would be the formation of partial negative charge on the oxygen atom and partial positive charge on the carbon atom. Because oxygen is more electronegative than carbon, so the electronic density will be more on the oxygen atom, and it will result in the formation of the partial negative charge on the oxygen atom. Now, since the electronic diversity of carbon has been shifted to oxygen atom, so therefore here deficiency of electronic density is generated, which results in the formation of partial positive charge. Now see this bond. In this bond, we know that there is a considerable electronegativity difference between oxygen and hydrogen. Electronic density will be shifted towards the oxygen atom because oxygen atom is more electronegative and it is attracting electron to a greater extent. Therefore, partial negative charge will be generated on oxygen atom and partial positive charge will be generated on the hydrogen atom. Now, because of the presence of these charges, these partial charges, there has been introduced polarity in the organic molecule. Now, since this compound is polar, therefore it will be soluble in these two polar solvents. The structure for a methyl alcohol is CH3OH. Now, this compound also contain an OH group, and we know that OH is polar covalent. OH has a polar covalent bond with oxygen having partial negative charge and hydrogen having partial positive charge. Now, since methyl alcohol is also polar, similarly ethyl alcohol is also polar, therefore all the organic compounds that are polar will be soluble in these polar solvents. Another property of organic compound is the similarity in the behavior, that is also called as homology. What kind of behavior? Behavior is assessed in terms of the kinds of reaction or the way with which an organic compound reacts. So sometimes there exists a close relationship between certain organic compounds, and because of that close relationship we classify these organic compounds into few families. So, series of related compounds in which any two adjacent molecule differ by CH2 group is called as the homologous series. For example, we have a case like this. This is called as ethane. And we have another compound. This is called propane. Now, if you observe these two compounds, you will notice that these two compounds differ only in one group, that is the CH2 group. So, all those compounds that differ by CH2 group are termed as are classified in a single homologous series. These compounds belong to a single class of compound, and these compounds have nearly or closely similar properties. So therefore they are present in a one class of compound. So since both these compounds are differing only in CH2 group, therefore they are present in a single homologous series. Let's take another example. This is an example of methanol, and this is a compound that is called ethanol. Now, if you relate these two compounds, then you may notice that these two compounds differ only by CH2 group. So this means that these two compounds belong to a single class of compound and they show similar behavior. So this means that they are homologues. They are present in a single homologous series. So all the compounds that are present in a homologous series behave similarly, and that behavior is similar because they have the common functional group and they differ only by CH2 units. Now, all the organic compounds have the slower reaction rates, and they are less stable than the inorganic compounds. So these were the general characteristics of the organic compounds that we read today. We will start our next topic in our tomorrow's lecture. Thank you for being with me.